Hi, Heron and Riverside Scholars. It is Miss Fack here from Heron, and we're going to continue on with Unit 4, Work and Power Notes. So make sure you have a sheet of paper out to take notes or that you are using the notes from the guide from last class. Today we're going to be talking about power. So what is power? Power is the measure of how quickly work is done. In last class we looked at work, so pause the video and review work if you are not sure what work is. Power is also how quickly energy is changed from one form to another. Make sure you pause the video and write this definition down. So our equation that we will use for power is W equals PT. Power is signified by the variable P, and it is measured in watts. Work is W, measured in joules, or J, and T is time, measured in S. Notice that 1 watt is the same thing as 1 joule per second, so we may see those units interchangeably. Make sure you have the definition and units written down. So we're going to determine, in these situations, is power being used? When a weightlifter picks up a set of barbells, is power being used? Well, we can think back. Is he doing work? And is it over a period of time? So yes, he has to do work. He's moving, he's using a force over a distance. So yes, work is being done, and he's doing it over a certain amount of time. So yes, power is being used. When a weightlifter holds the barbell over his head, is power being used? No, it is not being used because the barbell is just sitting there, so the barbell is not traveling any distance, so work is not being done, so thus power isn't occurring. What about a spaceship floating through the outer space without using its rockets? Is power being used? No, there's no work being done, so thus power is not being used. So what does this tell us? Looking at these examples, we see that every time work is done, power is used. All work takes some time, so if we do work, we are doing it over some period of time. Anytime work is not done, no power is used. So we said our equation is P equals W divided by T, or power equals work divided by time. If W equals 0 joules, then P will have to equal 0 watts. So if we look at our relationships, of course, P and W have a direct relationship because they're on opposite sides. So opposite sides have a direct relationship. If power goes up, work will also go up. W and T are also on opposite sides. So as work goes up, time will go up. And P and T are on the same side, so they have an inverse relationship. And that makes sense, because like if we look at P and W, if you increase your power, you're increasing the work that you're doing. If you're doing more power on something, then you'll have more work. Or if we look at work and time, if we increase the amount of time something takes, you're increasing the work you're doing. If you were at work, like at your job for longer, you're working longer, your time is greater. And then if we looked at P and T, if you increase the amount of power that you're going at your job or that you're working, you're going to decrease the time. If you work really hard and increase the power that you're doing your homework at, it won't take you as long. It'll be less time. So you can just think logically about those relationships as well. Here's an example problem, and we are going to do this the same way that we do any physics problems with equations. So if you do 30 joules of work to lift a box onto a shelf, what is the power it took you if it took you 10 seconds? So we're of course going to write our straight across equation, which is W equals P times T. And then we rearrange to get P equals W over T. So then we do 30 joules divided by 10 seconds, which will give us 3 watts. You must have all 4 of these steps in order to get full credit on a problem like this. Here's another example problem. 55 watts of power is used in lifting a barbell. How much power is used in lifting a barbell twice as heavy, the same distance in the same time? So right away I'm thinking power. Okay, if something is twice as heavy, it's probably going to be harder to lift, so thus I'm going to need more power. So I'm thinking power and weight are going to have a direct relationship because, of course, you will have to do more work. So looking at our equation, in this situation, our work was twice as much work we had to do, so then our power was twice as much, so we did 55 watts times 2 gives us 110 watts. A job can be done slowly or quickly. Both may require the same amount of work, but different amounts of. Okay, so if I'm doing the same amount of work, it's done quicker. Say if I'm doing it quicker, then twice as much time, then I have to have more power in order for those to be equal. So this, if I thought about it with my equation, if I did twice as much time, I would just have to, if it took me twice as long, twice as much time, I would be moving at half of the power, or divide the power by 2. And those are the end of the notes. Make sure you complete your IEP before next class and let your teacher know if you have any questions.